All right, CNT120, Chapter 3, we're moving on to IP addresses. IP address, this is assigned to nearly every node, every interface on a network, whether it be a computer, a printer, IP phone, or router interface. Typically, all of those are going to have an IP address for that network. These can be used to find a computer network, especially if it's connected as a public IP on the public network. Excuse me. These typically get used for routing purposes to get the data to the correct network. As we said previously, I think I have it here in my next slide here. Remember, MAC addresses, physical addresses, are going to get used to get the data to the correct device on the network. You know, my PC as opposed to my lab partner's PC. But the IP address is going to get used to get the data to the correct network. The York campus of Hack as opposed to the Gettysburg campus of Hack. So my routers, I think I have the picture here, as data is coming from the internet, if you will, the IP addressing is going to get used to route that data to the York campus as opposed to the Gettysburg campus. Once it gets routed to the York campus, the IP, the router here is like, okay, it kind of wipes its hands, like, okay, I'm done with y'all. Once it gets in the door, then your switch is going to read the MAC address to get it to my computer as opposed to my lab partner's computer. So keep that in mind. Your IP addressing is really there to get the data to the correct network. Once it's there, my MAC address is getting used by the switch to get it to my computer as opposed to my lab partner's computer. That's what's going on. So kind of use that to keep yourself sorted out as you're looking at all these addresses. So IP addresses are getting used for routing purposes to get it to the correct network. And as we said before, here's a bunch of different names for our IP addressing. Logical address, there is some logic to the octets on what they mean. It is software. I'm setting this in software. I can change this in software. It is a layer 3 address or a network address. That's the layer of the OSI model where this occurs. I do have IP version 4 and IP version 6 addresses. IP version 4 is 32 bits long, typically written as 4 decimal numbers, like so. And we did run out of IP version 4 addresses a number of years ago. So IP version 6 addresses have come along as a replacement. Most networks are running both right now, with the idea that down the road we're going to be migrating over to IP6. The IP version 6 is 128 bits long, so 128 ones and zeros, but it's typically written in a shorthand fashion of using hexadecimal numbers. So here would be my hexadecimal number representing my 128 binary bits. So as I look here, this is 8 bits, followed by this is 8 bits. And so if I were to multiply all that, I end up with my 128 bits there, 128 ones and zeros. As we said, our networks recognize logical and physical address, IP, as well as MAC address. And as we said, their purpose is your IP address is to get the data to the correct network. Once it's there, the MAC address is going to get used to get it to the right node in that network. That's the easiest way to explain these two addresses that you have. We can assign static IP addressing. Sometimes this gets done for devices like printers, servers, that sort of stuff, so that I know it always has that IP and I can always find it in my network. Think about if your printer IP changed every day, you would have to like remap your printer every day to be able to print to it. That would be slightly annoying. So certain entities on my network are going to have a static IP so that I can reach them all the time. This is typically assigned by your network admin. And I literally go into the TCP/IP settings and apply that address. However, if I had my regular users in the network apply the IP address setting statically, there would be a lot of duplicates, there would be a lot of errors, there would be a lot of things not functioning because of that. So typically your regular user computers, laptops, desktops do not use static IP addressing for that human element, if you will. My static IP addressing, though, I can set, here's my Windows setting, I can literally set the option that says use the following. When I do that, these boxes open and I need to plug in the correct IP subnet mask gateway, including DNS down here, to have this function on my network. It's a lot of settings that have to be right. That's why typically we don't let regular users of the network do that or have to do that. So typically regular users, regular computers, laptops in a network, we will assign them for dynamic IP addressing, which means when they boot up, they get their IP address from a DHCP server, a Dynamic Host Configuration Protocol server. It's there as kind of like an IP address lending station. It loans out an IP address and takes it back when you're done and then loans it out to somebody else. As I like to say, it's kind of like your bowling shoe rental counter. Loan the shoes out for a while. When you're done, I'll take them back and I'll loan them to somebody else. That way, this is done so the user does not have to plug all that information in. The server goes, use this number and you'll be fine. Use this number and you'll be fine. This allows users to literally just kind of boot up. It gets an IP and away they go. So in my Windows IP settings, if you have the obtain IP address automatically, you're setting it up for a dynamic IP. And the server will fill in all of these boxes for you with the correct numbers so that this is usable, this device is usable on the network. I'm going to throw this out now and I'm going to remind you later. If by chance my computer is set up for obtain IP address automatically, and I'm not able to get a connection or get communication with the DHCP server, my computer typically will self-assign a number, a PIPA, automatically privately assigned IP address. What it does is it tries to contact the DHCP server, tries a couple times, and if it can't, for various reasons, if it can't contact the server, it's like, oh well, kind of shrugs its shoulders, and it self-assigns an PIPA address, automatically privately assigned IP address, and it uses the address range of 169.254, blah, blah, blah. Now, I'm mentioning this because if my computer is set for dynamic, obtain IP address automatically, and it can't get communication to DHCP server, it'll self-assign this. Well, this right here is not routable on the network. You're not going to get out through your network, out through the router, out to the internet, out to your internet resources. It's not going to work. So if you end up checking a workstation or helping somebody check their computer and you see a 169.254, usually you do not want to see this. It usually means you're set for dynamic and you don't have a connection to DHCP server, so therefore you're not getting a valid IP. It's self-assigning. That's a troubleshooting red flag. I typically don't want to see this. I typically want to recheck the IP settings and try to get a valid IP address from the network. So I'm pointing that number out now. That's a little troubleshooting red flag. All right, if I were setting the IP address statically, or I'm looking at the IP address that was set for me, I will find the top line is my IP address. This is identifying this computer. This is used to identify this node on the network, but at layer 3. The MAC address at layer 2, IP address at layer 3. The next piece of info is the subnet mask. Well, the subnet mask lets us know what part of the address is network and which part is host. Well, example, if I have the address, 123 Main Street, Mechanicsburg, PA, we know Main Street, Mechanicsburg, PA is like the street in the town. And we know 123 is the house number. We know that. On a network, I can have a couple of these numbers mean the network, and one of these numbers typically as the host or the house number. So in IP addressing, when I look at the subnet mask lets me know, kind of what is the street address, and then what part is the actual house number. So when I look at this, the 255s are letting me know this is the network piece. That's the street address. And the 0 on the end is letting me know the house number or the host number. So as I look at my subnet mask, right here it tells me these first 3 numbers are the network. And this last number here is the host. That's what that tells me. That is extremely valuable, extremely useful, and as a network admin, it's something you'll need to be looking at and paying attention to, so I know where is this thing. The last number down here is the gateway. This is the address of the router that I'm typically connected to that's going to get me out of this network and typically out to the internet. It's usually my gateway that's going to get me out of this network and out to the internet. That's typically what this is. Last but not least is DNS down here. This is the address of the server that can help me resolve a name that I type in, formula1.com, into an address that I can actually communicate with that server and get the web page. So this is the address of the DNS server that will help me resolve names into numbers. If I want to look at my IP addressing on a Windows machine, I'm going to use the ipconfig command. So I'm going to go back here to my command prompt, and let me clear my screen. I'm going to do ipconfig, and this will let me know the IP configuration of my system. Here's my wireless network card. Right now, this is the IP version 4 address that I have. Here's the subnet mask, and here's the gateway. So that's my IP addressing on this machine right now. If I'm on a Linux or Apple computer, I'll use the ifconfig command, and I start seeing the IP addressing down here. I do run into, with IP version 4 addressing, subnetting, which is a piece of the whole. We will spend more time in this in a later chapter, but just to get the basic idea, a subnet is something that a network admin would create and allows us to start organizing our network. Well, think about in your house, you have a room for, kitchen to cook in, you have a bedroom to sleep in, you have a living room to watch TV or play games in. Those are pieces of your whole house, and they each have their own little function. When in network, we do the same thing. We'll break this large network into little pieces. This little piece for maybe the wireless users. This little piece for the employees. This little piece for the IP phones. And that is something that actually gets created by your network admin. And what they'll do is they'll take this whole network here, and they take a chunk of it. This right here, that number looks funny. They take a chunk of that and break it up into pieces, so now we have subnets. And now we can create a 32 subnet for the desktops, a 64 subnet for the IP phones, and a 96 subnet for the wireless users. This is a piece of the whole, and this helps us organize and eventually start doing some security and filtering on these various parts of my network. Just stick that idea in the back of your brain for now and recognize, here was the normal subnet mask, and down here is this subnetted subnet mask. This is something we do in 125, CNT125. We spend time doing this, implementing in this, and making this work. Get back here. Here we go. Again, there are two types of IP addresses, an IP4, IP6. If we look back in time, your IP version 4 was developed in the 80s. It's a 32-bit number, so 2 to the 32. 2 because we're binary. Okay, binary is 1 and 0, so there's 2 possible digits to use there. And since there's 32 bits, 2 to the 32 tells us there are 4.3 times 10 to the 9, so add 9 zeros, possible IP addresses. Well, those have been expired. So in the 90s, and for a lot of people, they became aware of this in the early 2000s, an IP version 6 address was developed. This now has 128 bits, so 2 to the 128 gives you a possible IP address pool of 3.4 times 10 to the 38, so add 38 zeros there, possible IP version 6 addresses. And with that scheme, it's anticipated that we should not run out of IP addresses now. Just putting that out there. Remember, content page, I have reminders on binary conversions. That's going to be handy as you work with IP addressing. My IP version 4 address. Let's actually come back in the next podcast and we'll go through some details of IP4 and then IP6.